I picked this problem because it looks like the thing I told you to do with rollerblades and that merry-go-round thing. However, this is not an R theta problem. It's a normal tangent because it involves velocity. The other thing is, right here, I wrote that you're given a tangent is 0. But the actual word problem, if you read it, it says something like the guy is increasing the speed very, very slowly. That was code for tangent acceleration was 0. Okay, so this ends up being a normal tangent problem with a radius 1.5 meters. And let's see what we can do. So let's draw the free body diagram of the girl. And I'm going to just use a top view. And since she's a particle, I'm just going to draw a dot. Okay, so there is a force of weight going into the paper and a normal force coming up out of the paper. But that's not relevant to us. Okay, and so then I'm just going to say, and then this is the normal direction, and that's the tangent direction. And so I'm going to say there is a, I'm going to call it friction force, normal, and a friction force tangent. We'll break it down like that. Okay, so that's the force, and that will equal MA. So we have M, from the top view, I drew the direction wrong. They're spinning clockwise, not counterclockwise. So let me redo this. It should be like this. They're moving this way. That's the tangent direction, because remember, normal tangent, the tangent is always in the direction of the motion. This was correct. It's actually not going to change a problem at all, but just to be correct. The mass of the girl times A in the tangent, and the mass of the girl times A in the normal. Okay, and we are given that a tangent was 0, so that was 0. And so very quickly, if you just look at the picture, if the tangent acceleration is 0, the tangent force is 0. Okay, so we then get F, this friction normal force, will equal just the mass of the girl times the normal acceleration, which we know is v squared over r. Okay, so we should be able to solve for v squared if we could figure out the normal force. The friction force. And the friction force is just the normal force times mu. And I guess let's draw the free body diagram in that direction. And so I'm going to just draw the girl as a block. I don't want to have to sketch her out. There's the mass of the girl times g is her weight. That's the weight going down. There's a normal force coming up. And the merry-go-round is not moving up or down, so there's no acceleration in that direction. And so we get, as usual, the normal force in these kinds of situations is just the weight of the girl. So I'm hoping we're given the mass, yes, 25 kilograms times 9.81, so that comes out to 245 newtons. And so then we get from the normal equation, from the top view, we get the friction force is mu times n. So we get Fn is 0.3 times 245, okay, equals the mass of the girl was 25 times v squared, and the radius that they're spinning around is 1.5 meters. And now we can solve for v. And this comes out to 2.10 meters per second. I'm beginning to wonder if I should have stuck to doing the examples in the book. The problems in the back are much simpler and much easier than the examples he does in the text. But anyway, let's continue.